everybody, Mrs. Jacobs here, and we are in Fellsmere, Florida at Triton Submarines. Hi everybody, I am here at Triton Submarines with the engineer, Jarl Stromer. So tell me a little bit about yourself and what you do here.
All right, well,
You want to hold it?
okay, that's fine. We build submarines here. Actually, what we do is we build submersibles. And let me start by telling you the difference between a submarine and a submersible. The submarine is like the military has. It goes from point A to point B, long distances on the surface. A submersible, you would put it on a boat, take it to where you want to dive, and then the boat would have a crane on it that would lower the sub into the water, and then you would go diving. And when I say submersible, I'm referring to this thing right here behind me.
Okay, so this is a submersible, not a submarine. A submarine is a little different.
Yeah.
So you could use this for fun? Like, what would you use it for?
Well, that's a great question. Right now, it's designed and built to be and is a very sophisticated scientific tool. You can dive, you can study natural, species, fish, all kinds of marine animals in their natural habitat. So you could do that. But if you buy it and you play with it, well, then it's the world's most expensive recreational vehicle.
Very expensive. But yeah, you could study ocean life and this big glass part of the submersible. You could see so many different things. So, how does this submersible work?
Okay. I mentioned earlier that you have a crane on your boat that picks up the submersible and puts it in the water. Once you're in the water, it's floating on the water, and it floats on the water because these big gray tanks are filled with air. And so that acts like swimmies. If you have swimmies on, you're in the pool, it keeps you from sinking. So these tanks filled with air keeps the submersible from sinking. Now, when we want it to sink, which is really the whole point of being in a submersible, we open the valve on the tank, the air goes out, and the submersible goes down. It becomes, we call it neutrally buoyant, which means it has the same weight as water. So when it's underwater on its own, it doesn't go up, it doesn't go down. And that's similar to the way a hot air balloon works. A hot air balloon just makes it itself a little bit lighter than air, and it goes up. Then when you want to come back to the ground, a hot air balloon makes itself a little bit heavier than air, and it comes down. Well, this thing works the same way. When you're a little bit lighter than the water or less dense, it goes up. When you're a little bit heavier than the water or more dense, you go down. So once you're underwater, you're looking out through this transparent ball, or we call it a sphere. That's the name of the geometry. This is actually 6.5 inches thick, but it's so clear that you can see right through it, and you can't really even tell how thick it is. Mm-hmm. There's 3 people can fit inside. The 3 people would get in, they would close the hatch, and then you would go diving. Now, once you're closed inside of this ball and you keep breathing the oxygen, eventually you're going to be running out of air. So the submersible has its own life support system that gives you more air to breathe while you're in there, and it lets you stay inside this sealed ball for up to 10 or 12 hours.
I said that you could see through the glass. When you're under the water, though, is it super dark, or can you see up to a certain point?
Water filters out the sunlight. Mm-hmm. So when you're just under the surface, you can still see the sun. As you go deeper, it gets darker and darker and darker. And depending on where you are in the world's oceans, some oceans are clearer than others, but eventually you're going to be in an area that's pitch black. And that's why we have lights on the submersible.
Those are cool.
So that we would be able to see everything around us and see the fish and the sharks and the octopus.
That follows you outside or inside?
We do. This one doesn't have a camera on it, but yes, normally we would have cameras facing forward, facing back, because when you're down there and you see something important, something interesting, you want to get a camera on it. And anytime you see not every time, but sometimes when you see fish and coral reefs underwater, the camera's in the sub, but you don't see the sub because the camera's pointing at the reef and the fish. So that's how that goes.
Okay, friends, here's another submersible, but this one looks a little different. Why does it look so different?
Well, the submersibles are different based on the different things you want to do with them. The first submersible that we looked at dives to 3,300 feet deep. That's pretty deep, but it's also very big. So if the crane on your boat isn't big enough to lift that, you can buy a cheaper or smaller, lighter submersible. It's also cheaper. And this would be an example of a smaller, lighter submersible that you would probably have less trouble picking up and launching over the side. This submersible has some interesting features that the first one didn't have. And the first feature you might notice is this big robot arm. So when you're in the water, you can work a joystick from inside the ball so that this robot arm can pick things up, and you can, whatever it is you see, you want to be able to interact with your environment, not just look at it. And that's why you have the arm there. Okay, now we're at the backside of the first submersible that we looked at. And I just wanted to show you some of the systems and equipment that are required for the submersible to work. It's all electric. There's no gasoline, no engine like that. So it runs on batteries. So we charge it up overnight, and the batteries are located inside these big cylinders here. The batteries send the electricity through the blue cables. And the blue cables goes into this part right here. And that part controls all the electricity. It sends the electricity to the propellers or to the various pumps and compressors that move the air and oxygen around. And the electricity would also go to your lights and your thrusters. We can slowly move this way, and I can show.
Yeah.
This is a thruster right here. The submersible has 4 of them. You can call them a propeller. It does make the submersible move underwater. We call it to maneuver. Like I said in the beginning, it doesn't go long distances sideways. It goes up and down mostly, but you still want to be able to steer it. And that's what you use the thrusters for. And you would, with your joystick input, the computer in the sub would know how much electricity to send to each thruster to make it go where you want it to go.
Can it go forward?
It can go straight forward. It can go sideways. It can spin on its axis. And it can go up and down.
Okay. Hi, friends. It's Mrs. Jacobs, and I'm inside the submersible. It's super, super small in here, but you can fit 3 friends in here. Would you want to go inside this submersible?
Yes, please.
Submersibles. What is this big, huge submarine?
We've been building submersibles since about 2007, and the whole time we've been doing it, we've been getting better at it. So we've been building them bigger and deeper diving. And this is an example of a larger plastic ball. Or sometimes they call them bubble subs too, which is a good thing for them.
Bubbles.
So this one fits 6 people inside, whereas the first one was only 3. The second one was also 3. This one is 6 people, and it will dive to 3,300 feet deep. So that's very, very deep. And again, it's all pitch black down there. So you have lights on the front. All the wires are inside. They go to, for example, there's an air conditioner inside.
Good.
There's a radio inside. All kinds of instruments that continuously measure how much oxygen is in the air, how much carbon dioxide is in the air.
That's super safe. What is that circle up there?
That's the hatch.
Is that how you get in?
That's where you get in. You can see the top of the hatch is up there.
Yep.
And then when you close the hatch, it seals the ball.
Uh-huh.
And then you turn on your life support system. And then you let the air out of your swimmies. And now you're diving.
Yep, then you can sink. Right, friends. So in science or STEAM, we've talked about making a plan before you make something and keep improving and getting better on that plan. So what I have here is a little model of a submarine. This is a tourist submarine, which means you could have anybody come and sit in the submarine and do a little tour of what's under the ocean. This looks like it's 24, you said?
24 seats.
24 seats. You could sit in there and look out the windows. And this is a little model. This is a little model of the other submersibles.
It's actually a model of the last one we looked at. So although it's yellow here, it was dark blue.
Dark blue.
Out in the shop.
So why is it different colors? Does it matter the color?
In the old days, you wanted the submersible to have a bright color so that you could see it easily.
Nice and bright.
Today, we have a lot of instrumentation that allows you to track the location of the submersible. So it doesn't have to be a bright color. As a matter of fact, now people want the color of the submersible to match the color of their ship. So we'll paint it any color you want.
Awesome. That looks really heavy. What is that?
So this is a window for a submarine or submersible, sorry. This window has been designed to go all the way to the bottom of the Marianas Trench in the Pacific Ocean, which is the deepest point in the ocean. So these windows
are
in
this is a
submersible.
Yeah.
And this, like I said, has dived to full ocean depth.
And this is just a small model. You had the big one.
The big one is out there on the back of a boat, getting put in the water and diving in. So when this one is designed to go so deep that it can go to 36,000 feet. The Titanic is at 12,000 feet. So this one has dived to the Titanic, and it was considered a shallow dive.
Oh my goodness. So it has gone that deep.
It has gone to the Titanic. It has gone to the bottom of the Marianas Trench.
I was just going to ask that.
So it's been 36,000 feet
deep in the ocean. That's crazy.
So the bubbles on our bubble subs are made of plastic. It's called acrylic plastic, and I have a block of it right here. The reason why it's better than glass is that it doesn't shatter. You can hit this with a hammer and it wouldn't crack, it wouldn't shatter like if this was glass and you hit it with a hammer, 100 pieces, 1,000 pieces all over the place. So the thickness that you see here is the thickness of the bubble on that first sub we looked at. The thickness that you see here is the thickness of another sub, and then our thickest sphere is that amount of thickness there. And I'm going to show you. Take the video from here and see how clearly you can see the book. And you could read it through that amount of acrylic plastic. So it's a good material. It's strong. It's tough. It doesn't shatter, and it's see-through. That's the most important thing, because you don't want to be inside of a solid steel ball and not be able to see out. Then what's the point of going there?
So I said that Jarl is an engineer. What is an engineer? Do you know what an engineer is, friends? Jarl is going to explain what an engineer does at Triton Submarines.
Okay, so my education is as a mechanical engineer. Electrical engineers work with electricity, and mechanical engineer works with solid things, things that you can hold, like a mechanism or the ball itself. You know, that ball protects the people that are inside from the water outside. And we have to make sure that the ball is strong enough to be able to do that so that it won't collapse, which would not be good for the people inside. And so, one of the things that the mechanical engineer does is do calculations, figure out using math if that thickness is going to be thick enough for depending on how deep you go. So that's one thing the mechanical engineer does. We produce drawings. This is a schematic drawing that actually is showing our air conditioning system.
Okay, friends. So this is a picture of a model of the ocean. This is sea level, so this is the top of the water. And then it goes deeper and deeper. It tells you like some lakes, how deep they go. At this point of the ocean, if you put your bike tire or your bike in the ocean, your bike tire would just go flat at that point. Because the ocean is super, super, once you go deep into the ocean, it's very, very heavy. The Titanic is at 3,000 meters, 4,000 meters. So the Titanic is at the bottom of the ocean. That's a big ship that sunk to the bottom or sunk in the ocean a long, long time ago. And then this is where that gray model of the submersible that we saw.
That's the white one, actually.
The white one.
The white one with the titanium ball.
Yeah, with the titanium ball. That's how far it went, the Marianas Trench. And that is almost 11,000 meters deep into the ocean.
Yeah. And we set a record that it went to we've gone the deepest of any person ever. Before we went there, there had only been two other trips down. The first trip was made when I was born in the early 1960s, and then it was not repeated until 2012 when James Cameron, the famous movie producer, built a submersible and did it for himself. He was in a metal ball kind of tucked in like this. When we did it, we had a metal ball for two people, and it gave you a little bit more room.
Well, that's
but
awesome.
again, but we've done it now repeatedly. So whereas before we got there, that had only been three people that had ever been that deep, and now I've lost count. There's dozens of people that have taken our sub.
Has James Cameron ever done business with you guys?
Yes. Coincidentally, James Cameron has invested in our company. He's very interested in ocean exploration and conservation. And so, yeah, he actually has invested in Triton, and so he owns part of the company.
James Cameron is the person who wrote the movie The Titanic. And so an engineer, a mechanical engineer for Triton Submarines, creates these drawings on the computer. At one point, I'm sure you drew them by hand, or people drew engineering drawings by hand. But now everything is done on the computer. And friends, this is the cover for is this a submarine or a submersible?
It's still a submersible because you charge it up with the batteries and you bring it out to the dive site with the ship. You put it in the water. Actually, this one has a garage where the submersible actually just goes out from the back of the ship. It actually has its own garage.
Wow.
In the back of the ship.
This one's big and it has lots of windows. It looks very different than the other submersibles.
This is more of a traditional shape.
Yeah, this is what, if you see a submarine, you might call this a submarine. It's a submarine shape. Okay, friends, in science, we talk about having to test things out. So you're probably wondering, how do they test these submarines out? They can go to the ocean, but they have something special right here at the shop. I'm going to walk up these steps. And here is a testing diving pool where we could put the submarines in, or submersibles in, and test them out however you need to. It's actually 2 shipping containers put together, pool liner, and then some water. So you could test out your thing that you made to make sure everything's going good. Okay, friends, thank you for joining me on our field trip to Triton Submarines in Florida. If you have any questions for the engineer, the mechanical engineer here at Triton Submarines, fill out the Microsoft form, send it back to your teacher, and I will be in touch, and Jarl will answer any questions that you have, and we could see him again soon. Thank you, friends. Bye.